So we're doing sum and difference. You have, well, according to the book, you have 4 formulas. They actually gave you 6 formulas, but we're going to ignore the tangent formulas. I am not requiring you to know the tangent formulas. I am not going to give you anything on quizzes or tests that require you to use the tangent formulas. So just the sine and cosine formulas. They give it to you as 4 formulas. I'm going to give it to you as 2 formulas. So you can decide how you want to do it. The sine formula, what we have is we have addition or subtraction inside of here. What I'm going to do is I'm going to do it as a plus or minus. So whenever there's a plus on the inside, there's a plus over on the right side. Whenever there's a minus sign on the left side, there's a minus sign on the right side. That's the only difference between the 2 formulas. So like I said, in the book, they give it to you as 2 formulas. And I'm just going to do it as the one because that's the only difference between the formulas is what sign you have. Now, cosine is a little bit different. First of all, notice that instead of being split with sine and cosine, we have all cosines together. Also, the signs get reversed. So if I have a plus sign on the left-hand side, I have a minus sign on the right-hand side. Yes. So if the left-hand side is a plus, the right-hand side has to be a minus. If the left-hand side is a minus, the right-hand side has to be a plus.
I wonder, why is it negative on that?
Because they have to match up. If this is a plus, this is a minus.
Okay.
If this is a minus, this is a plus.
But you didn't do that for the sign.
Nope, because the minus, they're the same. If this is a plus, this is a plus. If this is a minus, this is a minus.
Where are you getting that from?
That's your formula. So here. This is how your book presents it. So sine of 2 things added together. There's your formula with an addition sign in the middle. Sine with 2 things subtracted. Here's your formula with a subtraction sign. Cosine with addition, you get over here with subtraction. Subtraction, you get addition. Yeah. Yeah, this is, no 5-4. This, yes. That's what I heard. It's going to be gone. I don't have it anymore. It was a YouTube malfunction. I have no idea. YouTube told me it was fine, so I deleted it. It's gone.
It was that 5-3.
Huh? I don't have it.
You deleted off your flash drive.
My flash drive can only hold so many, no. Those videos are like 2 gig a piece. I can't save them. They take up too much space. So I upload them and delete them.
That was 5-3A.
Out of 2 years, I've never had that happen. That's the first time I've ever had that happen. So yeah, I've never saved. I don't normally save them. Yeah. So I still have the paper copy of the notes. I just don't have the video.
You should like take a short video of this and put it on YouTube.
Okay. So let's use this. So this is how type of problems you're going to have. You have one type to ask you to find the exact value. So exact value means that you're going to be using your unit circle. However, we do not have 75 degrees on your unit circle. How can we combine things on your unit circle to get 75 degrees? I don't want to use red. So what this is asking you to do is take 75 degrees and split it into numbers that you do have on your unit circle. Yeah. 90 minus 15, but 15 is not in your unit circle. 30 and 45 are. So I can take 30 plus 45. Now I'm going to use my formula that I just had. This is cosine of 30, cosine of 45. Since this is a plus, it becomes a minus sign. Sine 30, sine 45. Now I take and I just plug in the values of those. So cosine of 30 is square root of 3 over 2. Cosine of 45 is radical 2 over 2 minus sine of 30 is 1/2. Sine of 45 is radical 2 over 2. So this is radical 6 over 4 minus radical 2 over 4. If I want to simplify that a little bit, this is all the more I can simplify it in order to have an exact solution, which is what they're asking for.
So what was the cosine x plus minus y one
Mm-hmm. Okay, let's do another one of those, but we're going to practice with radians. Because degrees are easy. You know, you guys are used to adding and subtracting numbers with whole numbers, but how about fractions? How can I get pi over 12? You don't have pi over 6. But you're on the right track. Try that one. Because I need it to be in 12ths, right? So if I go through my circle and change things into 12ths, pi over 3 would be 4 pi over 12. Pi over 4 would be 3 pi over 12. And then if I subtract those, I get 1 pi over 12. So if you're looking for a certain denominator, take all the numbers in your unit circle and change them into that denominator, and then look at adding and subtracting and see how you can get them. So change everything into 12s and then see how you can get it. All right, so I'm subtracting with sine. Now, with sine, notice that order does matter, especially when we're doing the subtraction. So my first one, the sine has to have the pi over 3. Huh? Because if I would add these, I would get 7 pi over 12 instead of just pi over 12. Alright, so sine of pi over 3. No, I did it. I'm thinking, for some reason I was thinking I did the last one wrong, but I didn't. Okay. Sine of pi over 3 would be square root of 3 over 2. Cosine would be square root of 2 over 2 minus square root of 2 over 2 and 1/2. Huh. You can get the exact same answer. Okay, so that's one type of problem. Okay, then I want to do a couple of verifying problems. Okay, so let's verify this. Alright, well, there's not anything we can really do with the right-hand side at all, so let's just expand the left-hand side using our formula. Since this is a minus with the cosine formula, it turns into a plus. Okay, so we get that. We start simplifying. What's cosine of pi over 2? It's 0. Because pi over 2 is up at the top, the ordered pair up at the top is 0, 1. So cosine is the x value, so that'd be 0. The sine value would be 1. So then 0 times cosine of x would disappear. 1 times sine of x is just sine of x. So that one checks out. Yep.
I thought you said you have to show all the steps, so if you can't do one thing now, you have to put it down. You have to show all steps.
What do you want me to put down?
Like you remove the cosine of x times 0, and then 1 times sine of
So
x.
you want me to put down this?
Yeah.
Okay.
You're the one that came up with that rule?
There you go. Alright, so let's find a harder one. Sorry, I got down to the I ran out of time. I had to go and deliver something. So I didn't get your notes all the way done. So let's see. We need a harder one to verify. That one was too easy. Let's see. That was example 3. So example 4. Ooh, let's do one with X's and Y's. This is number 64, so this has to be the hardest because it's the last one of the verifies, right? So cosine of X plus Y plus cosine of X minus Y. And we have to prove that that equals 2 times cosine of X cosine of Y. I don't know. I don't think that one looks too tough. I don't know. This one still seems pretty straightforward. Because it's still, you just apply your formula, and I have a feeling a lot of things are just going to cancel out. So let's try it. So apply the formula to this. So cosine of X, cosine of Y, minus, because we have to switch signs with cosine, sine of X, sine of Y, plus, okay, so then I do this one, cosine of X, cosine of Y, plus sine of X, sine of Y, oh, this one's really easy. That was no fun at all. Okay, so this and this cancel out. Okay, these two are the exact same thing. So if I take two of the exact same thing and add them together, I end up with 2 of them. Yeah, that was no fun. That was supposed to be the hardest one. Huh? Oh, because I wrote it down wrong. I was just trying to copy that down and I just wrote it down wrong. That was like that was a fail. All right, so let's do some solving problems. Let's see, what can we solve? Let's see, for x in 0 to 2 pi, let's solve this. And we'll probably just have this one be the last one. I think you guys kind of get the point. Alright, so I need to solve that. Oh, very first step, whenever you see something like this, is to expand it. Because as long as that stuff is inside of the sign, we cannot do anything. Signs with different things inside of them are just like having different variables. It's like trying to take an x and a z and adding them together. You can't do it. So we need to expand them. If I have 2 sine of x's, then I can do stuff with them. So we take and we expand this. I don't like using brown. It reminds me of poop. Okay, so sine x cosine pi over 4 plus sine pi over 4 cosine x plus, okay, so there's the first one. Okay, so the second one, sine x cosine pi over 4 minus sine pi over 4 cosine x equals -1. Alright, so let's do some simplifying. Yep.
So when the problem has cosine, how do you know which use the cosine formula or the sine?
It depends on what has the addition or subtraction inside of it. So here the addition is inside sine, so I'm going to use the sine formula. Up here the addition was inside the cosine, so I'm going to use the cosine formula.
So if that was one cosine on top,
Like this,
yeah.
then I use the cosine formula. See, it's what it's inside of. If it's inside of a cosine, use cosine formula. If it's inside of a sine, you have to use your sine formula. Okay, this one and this one cancel out because they're the same exact thing, just one with a plus and one with a minus. Okay, these two are the same exact thing. And since I have 2 of them, I can combine them. Okay, so that actually makes it look a lot nicer. What is cosine of pi over 4? Square root of 2 over 2. Okay, so if I take that times the 2, I just end up with square root of 2. Okay, move that to the other side. Simplify that a little bit. Okay, so I'm looking for all the places on the unit circle. What? I divided it from both sides. I just took and I divided both sides by radical 2.
So how does that get rid of the radical 2?
Oh, how do you get rid of the 2?
This 2
Yeah.
canceled. One on top, one on the bottom. And then here I just simplified. I moved it to the top by doing that thing. Okay, places on the unit circle where it equals negative radical 2 over 2. Well, since it's sine, that means it has to be below the x-axis. Square root of 2 over 2 occurs at all the 45-degree angles, or the pi over 4 angles. So it'd have to be 5 pi over 4 and 7 pi over 4. So there would be my general solution, but I want my exact solution. Well, I don't have any weird numbers on here I have to divide by. So this is just going to be my solution. And this is normally your exact solution unless you have your multi-angle stuff going on where you have to divide by numbers. All right, so the concepts that we just covered, the verifying and the solving, will be on your quiz tomorrow, but the formulas that we just covered will not. So you don't need the sum and difference formulas for the quiz tomorrow, but we will be solving and verifying. You just need your regular formulas, your quotient formula, your inverse formulas, your Pythagoreans.